Okay, we want to see how this expression written out in linear fashion, the way you'd have to type it on a typewriter if you were using a computer algebra system. Let's see how what this really means, what it really looks like if you put it in standard mathematical notation. Y'all did this pretty well. Okay, so you got this thing, which is just x plus 1 over x plus 5. Parentheses are optional, we can just have one factor in the numerator and one in the denominator. So I'll go ahead and put the parentheses there. I just got putting it over the fraction bar, and under the fraction bar, it's already grouped. Then here we have a numerator of x squared plus 2x, denominator of x minus 3 and x plus 4. And there's a minus sign between these two fractions. Okay, everybody got that? Okay. Okay, that's good because I've got there's another thing that I need to do, security awareness training. Well, Halloween evening, I said, okay, I'm going to sit here, wait for trick-or-treaters who never come, and do the security awareness training. So I log into it, everything's going smooth. The first alert comes along, gets done, and then it blocks me. Can't block it. Email the help desk. Can't do it. Can't do it. And the deadline was that evening. Okay, so officially they can take away my network privileges now until I get it done. I don't know how I get it done if I don't have network privileges. But that's, you know, so just emails back and forth. So instead of doing that, I made up a bunch of problems for y'all. Okay, just practice problems with just answers, with factoring and adding and subtracting fractions. Okay, stuff with complex fractions is good. But since we're having as much trouble as we were with adding and subtracting, I kind of decided I was going to put that aside. Since y'all did it, we're going to do it because we do have time to do it. And it's good exercise. It's really good for understanding the intermediate algebra. We're really trying to focus on the intermediate algebra you need to do pre-calculus. Okay. So anyhow, try to print that. Okay, well, that didn't need to have that on camera, but it's okay. Okay. I think the screen is over to blurriness. Okay, so we have this. Well, there are two ways you can do this. Okay, one way is you can say, well, that's this divided by this. Okay. And that equals well, the very first thing we did in this course of fractions, we know that divided by fractions same as multiplied by the reciprocal. That's 4x times x plus 3 over 2 times x minus 5. This is in factored form. A lot of time you want to leave it in factored form. But since none of the factors match up, you're not going to be able to simplify this anymore. So you could then, depending on what open math, for example, asks you to do, go ahead and multiply this out. And that's going to be 4x squared plus 12x over 2x minus 10. So that's one way to get the result. Another way is you write out your expression and you find the common denominator between this and this. Common denominator with x minus 5 and 4x is just 4x times x minus 5. So we can multiply the numerator by this and also multiply the denominator. Okay, so if you want, you can put this over 1. Keep track of your numerator and denominator. And we can see that this numerator can be arranged as this. We still have the same factors in the numerator, 4x, x minus 5, and x plus 3. There's the 4x, there's the x minus 5, and there's the x minus 3. They're just going to be in different order. And we put the x minus 5 down here and the 1 over here, but this is still the same factors in the denominator. Since x minus 5 over x minus 5 is 1, this whole thing just becomes 4x times x plus 3. It's just going to be 1 times this over 1. And this over 1 is just going to give you this, and this times 1 just gives you this. So that all works out. In the denominator, you can write this as 4x over 4x times x minus 5 times 2 over 1. And again, we have the same factors in this numerator. 4x is here, the x minus 5 is here, the 2 is here. They're multiplied so they can be in any order. And down here, we have our 4x that we group with 4x. And the 1 here. Well, in this case, I'm going to actually permit cancellation. We have exactly the same thing here and the same thing here. And they're divided. You just cross this out and cross this out and make yourself a note that this is 1. Okay. I haven't thought about where's a good place to do that, but okay, we'll just call that one, just write a little 1 here. To remind ourselves that when we divide something by itself, it's 1. We can do this. Well, that's 1. So now we have this. But those 1s don't do anything. This 1 divides into this, it just gives us 4x times x plus 3. And 1 times 4x times x plus 3 is just 4x times x plus 3. Same in the denominator. So we get 4x times x plus 3. Over x minus 5 times 2x. It's not times 2x, it's times 2. I don't know where that x came from. Well, this is the same as this, and it multiplies out the same way. So the point is, that I might be overcomplicating things by emphasizing that you got to group the x minus 5 with the x minus 5 so you can cancel it. But I see too much incorrect cancellation. I want to really emphasize the process. Okay. If you can get it out like this, then they cancel. If you factor it out like this, then they cancel. Otherwise, they don't. Because as I said, I'll see people cancel this 3 here with this 3 here. There are 2 3s in the page. Boy, just cancel out all your 3s, just cross them all out. Makes things much simpler. Doesn't give you equivalent mathematical instructions, but it's simple. And people do things almost that badly coming out of our schools, especially after COVID. Okay. That's basically what you want to know about complex fractions, but what if you had a question on one specific problem? So let me work that one out. Okay. So there's a little confusion here over what the common denominator is. Some people want to say it's M. Okay. That's not really going to work. It's got to be M squared. It's like if you have 1/3 and 5/9. Okay. What would your common denominator be? We could say, well, 3 times 9, 1/3, 5/9, 3 times 9 to 27. Doesn't have to be that big. 9 will be enough. But you need 9. You can't just use 3. Okay, because, well, let's see how it works out. So I'm claiming that it's M squared. Really, all we need to do is multiply M squared times 0 over M squared times yes. Now, what's that going to give us? And write it this way, right? Distributive law M squared times X. And M squared times 9 over M, I could write as M squared over 1 times 9 over M. Denominator is this, okay? Now, how am I going to rearrange that? M squared. Okay, I'm going to write this. Instead of M squared, I'm going to write as M times M. I'm going to do this. Okay, I can write this as one of these M's. That's not, sorry, I'm looking at the wrong place. Okay, looking at this. Okay, I've got an M here that'll divide into one of these M's. So right there I have. I still have another M. I'll put that as an M over 1. I can write the 9 as a 9 over 1. Now, if I multiply out my numerators, I've got M squared here times 9, right? So right there's M squared times 9. The denominator is just M times 1 times 1. That's just an M. So the denominator is still the same as it was. Now, the M over M is a factor, and I can just say, okay, that's going to be 1. Denominator and a price for writing big. You make that out? No. Okay. So here I just put the m squared over the m squared, and the 81 over the 1. Now, if I work that out, the m squared over the m squared is 1. But I needed an m squared so that I could divide this m squared into it. That makes sense? Yeah, we're having some problem with that. Okay. Okay, so we're still kind of stuck on why you need the m squared. Well, you need it because you need to get rid of the m squared in the denominator, like we've done. Okay, if you come back up here, questions, why do you need the m squared if you don't need it in the numerator? Okay, you only need an m here, but you're going to need an m squared down here. I think we see that. So, well, the bottom line is you got to do the same thing here that you use here. You need more down here to get rid of the m squared. Okay, but to clear the denominator here, you're not really getting rid of it. Clear the denominator. And if you need an m squared down here, then you got to use it up here. That help? Okay, so okay, need m squared here. We've got to use m squared here. As well. Can't use a different thing here than you use here, because if you multiply the numerator by a different quantity and you multiply the denominator, you no longer have equal fractions. Or you no longer have the same fraction. Okay, the fraction changes its value. Okay. So again, the way you want to look at it is multiply that denominator by whatever it takes. They're going to multiply the numerator by whatever it takes. But I got to multiply both by the same thing. So I got to take whatever, so I got to use whatever it takes down here and whatever it takes down here and put them into one pot. That makes sense? Just an analogy. Does that work? Okay. Well, hang on a minute. Okay, I've been emphasizing I discourage cancellation, but to understand this, you really kind of need to use cancellation. Now, that's essentially what I've done with all these steps. This is a little more complicated. If you understand the rules for cancellation, and don't go crossing out every 3 you see on the page just because you cancel them, okay? And nobody's going to do that, but people come close, okay? And let me just digress. People's look at 2x plus 5 over x minus, now I'll show you go this x minus 2. Excuse me. And they'll cross out the x's. Then they'll cross out the 2's, and you just get 5 over a minus sign. Okay. Don't laugh, I've seen that. And what might not have been those exact expressions, but I've seen things that bad frequently. In pre-calculus classes, people are supposed to have had algebra 1 and algebra 2 recently. Okay, it's ridiculous. Cancellation just crossing out what you don't want. No, cancellation is crossing out factors. Okay, so I'm going to explain it in terms of this problem. Okay. So let's start again with x plus 9 over m divided by 1 minus 81 over m squared. Now I see if I multiply just repeating steps that I've already written down. Accepting that I need the m squared. And the way I look at it is, if I multiply this by m squared, the m squared down here is going to go away. Because of all this. We want to understand this. Once we understand this, we can do it safely. Well, I distribute. Maybe put the 1 under the m squared to keep ourselves straight. Okay. Well, what's m squared divided by m? It's m. Okay. So make a little note out here to make sure we understand that. This m will divide one of these m's, give you 1, and you just have 1 times m. Okay, so in that sense, I can toss these out. Okay. If we understand this, another way to do it is with the rules of exponents. M squared over m to the 1 is m to the 2 minus 1. But let's keep it as fundamental as we can. So we get those rules where they really build up. Also then, this is 81. Because this m squared is divided by this m squared. Gives you 1. Okay. Well, that's kind of the way we look at it, but we got to be careful that we don't look at things wrong. Okay, we've got to be careful that we can always do stuff I've been showing you. Okay. So what we can then do is we can say, okay, well, okay, there we go. Another way of doing this is you've got a first power of m here. And that gets rid of the 2. Because instead of m squared, we're just going to have m to the first power, right? It gets rid of the 2 and makes it into 1. So we kind of put it there. And then we got an m squared here and an m squared here. That just gives us 1. And what we've done now that's m squared x, right, the x, plus 9 times m over m squared minus 81. Again, visually, the way you see it is, I multiply this by m squared, it's going to clear that m squared. I multiply this by m squared, is going to clear that m, but I'm still going to have another m left up the bottom. Okay. Now, at this point, I don't want to spend any more time talking about complex fractions because there are more important things. It's something you really want to be able to do. And I'll put some of it on the test. But it's not as critical as other things we're going to talk about. We're going to talk about the most critical things so that you come out of here with as much intermediate algebra as most people have coming into pre-calculus. Okay. That's going to be our goal. Okay, last comment on this before we move on to square roots and radicals. Okay, we can do this as it's been done here, or we can do it this way. We can put this numerator over the common denominator m, which is fairly straightforward. Put the denominator of the common denominator m squared, so that this is still equal to this, and this is still equal to this. And then we can write that as this divided by this, which means it's this then multiplied by the reciprocal of this, which is here. And this can be rearranged with an m squared over m, which is just going to be an m over 1, okay? And then we multiply that by mx plus 9 over m squared minus 81 to get this, and this equals then m times mx plus 9 over m squared minus 81. And notice that this is exactly the same as this. So there are two routes we could take. So here's one route. But here's another route. Okay. Okay, well. We want to talk about square roots and radicals and something on the board space. I've got plenty. I'll figure out what to look. Can you show me with your hands what the square root of 25 is? Everybody knows it's 5. You're not just raising your hand because you want to say something. Okay. Yeah, I don't even like the fact that we need to raise our hands. You don't really need to raise your hands to say something. Just point to the computer. I can turn the sound off or turn the microphone off and you can start talking. You don't have to have permission, but I do have to have the computer off, right? Okay, so square root of 25 is what? It's 5. Okay. What's the cube root of 8? 2. Okay, why is that? Square root of 25 is 5. Plus 5 squared equals 25. Square root's just the flip side of the square. And you, again, wouldn't believe how many people have been through 2 years of secondary school algebra. Don't know the difference between a square and square root. Okay. So wouldn't have surprised me too much that y'all are disciplined enough to keep coming to this class and keep making the effort, which means that you've probably learned something. some point in the past. Well, obviously you have, okay? That other people didn't, and I don't understand why. Okay. Anyhow, that's different. So anyhow, now this is because this equals 2. That's 2 cubed equals 8. I can't ask you too many cubes to do in your head, okay? Because they start getting big. So, okay, so you have the basic idea. Now, I'm going to throw a little bit of curveball at you. Okay, now, I wouldn't have expected everybody to be able to tell me what the cube root of 8 was. Okay, not everybody did, because that's a different animal than the square. It's the same type of thing, but that's where it gets a little more complicated. Now you can recognize that the square root of 25 is 5. If I ask you what's the square root of 81, would you be able to tell me? 9 times 9 is 81, right? So if you know your multiplication tables, at least up through 10, you can find your squares pretty easily. Cubes gets a little hard. Finding cubes gets a little hard. So that's why I just wrote this down. And somebody told me, and I said, okay, now I know I need to explain that. Or I expect I need to explain that. It's because 2 cubed is 8. Of course, that means 2 times 2 times 2. 2 cubed means. Okay. Now, what's 3 cubed? Well, you don't have enough fingers, so don't even try. Okay, 3 cubed is 27. And you can easily work it out. 4 cubed is 64. Well, 3 cubed, 3 times 3 is 9. 3 times 9 is 27. Okay. 4 times 4 is 16. What's 16 times 4? You might not know that off the top of your head. Okay. So this is where you almost have to start writing things down unless you got pretty good mental arithmetic skills. Unless you've seen it a lot. And then 5 cubed is actually one you can kind of do in your head, because 5 times 5 is 25. And how much money do you have if you have 5 quarters? You have $1.25. Okay. So that one's kind of easy because of money. Now, a few more years, nobody's going to be using coins. Vending machines take credit cards and phones take pictures, and artificial intelligence does incredible things. We don't even know how. We just know how to set it up, let it go, and that can get dangerous. So, but it can also get very beneficial. So how do we control it? That's a big question. Okay, well, anyhow, that's a little bit of an extrapolation from 5 cubed equals 125. And then 6 cubed, 216, 7 cubes, 343, 8 cubed is 512, 9 cubed is 729, and I can go a little much further than that. 12 cubed is 28. And to think like that. Okay. Knowing these, working it out, 6 times 6 is 36. Multiply 36 by 6, you get 216. Fairly decent set of cubes. Don't expect you to know many fourth powers. 2 to the 4th isn't bad. Okay. Okay, 2 to the 4th. 2 times 2 times 2 times 2, right? Well, 2 times 2 times 2 is 8. 2 of those are 16. Then you go double that, you get 32. That's 2 to the 5th. Double that, you get 64. All that's pretty easy to do in your head. So you go all the way up to 2 to the 6th power. Pretty easily. But when you go 3 to the 6th power, okay, Well, if you know that 9 cubed is 729, you know that's 3 to the 6th, but okay. But I don't expect you to know that. You don't have to know that. You don't absolutely have to know this, but it's helpful if you do. Okay, well, that's what we know about powers. So we know what the cube roots of these numbers are. Okay, now with this much information, there are things I can do. Okay, for example, let's stick with square roots for a few minutes. What's the square root of 50? Well, you don't know, I don't know, it's an irrational number. I can't express it exactly, nobody else can either. Okay, it's about 70.7, 7.07 or something like that. Okay. But the one thing I can do with the square root of 50, if I can write that as a square root of, well, let's see, divide 2 into 50, that's 2. And that'd be 2 times 25, but that's 2 times 5 times 5. Okay. It turns out that there's a convenient rule for square root. If you got the square root of a bunch of things multiplied together, you can separate them out. You can't do that if you got a plus sign in here, but if these are multiplications, you can do this, okay? Okay, there's a question that we'll answer in a minute. I'm going to go on with this because I don't want to lose this track. So again, if these are all multiplied, then you can group them under different square root signs any way you want to. Okay, I group them like this. Well, what's the square root of 5 times 5? Well, one way to write that is that's the square root of 5 squared. What's the square root of 5 squared? It's 5. So we could write this as 5 times the square root of 2. Now another way, we can always break a number down into its prime factors. And if 2 of those prime factors match, then the square root of that match is going to be one of those. The square root of 5 times 5 is 5. Because 5 times 5 is 5 squared, and the square root of a square is just equal to the number. As long as the number is positive, we'll worry about the other case a little bit later. Okay, so a shorter way of seeing this is you can see that 50 is 2 times 25. Then square root of 2 times 25 is square root of 2 times the square root of 25, which is square root of 2 times 5. And we usually write the number out in front and the square root next to it, okay, to the right hand. Does that make sense? Yeah. Okay. Now, if I gave you You don't need to totally understand this. So I said, okay, cube root of 686. Okay. You better break that 686 down. Okay. That's a cube root of 2 times 343, right? I did my arithmetic right. Well, the next smallest number you can divide 343 by is 7. And you get 7 times 49. So 686, pretty easily, you can do this. Okay, just keep dividing by the smallest possible number. So you run out of numbers you divide by. And those numbers will all be prime numbers. And you see, we've got 7 times 7 times 7. Now, what does that suggest to you? We're doing a cube root. So we could write that as the cube root of 2 on the right here. Okay, cube root of 2 times the cube root of 7 cubed. What's a cube root of 7 cubed? Well, the cube root is a number you multiply by itself 3 times. What do you multiply by itself 3 times to get 7 cubed? 7, right? Okay. Okay, the camera's blurred out again. Let's see if we can advance it to focus on the picture. Okay. So good observation was that 7 times 7 times 7 is 7 cubed. So now we're going to have the cube root of 2 times the cube root of 7 cubed. What's the cube root of 7 cubed? 7 cubed is the number the cube root of 7 cubed is the number you multiply 3 times to get 7 cubed. What would you multiply 3 times to get 7 cubed? Well, obviously 7, right? So that this is cube root of 7 cubed is just 7. Okay. So there's some rules that we can use in dealing with these things. Okay, cube root of 343 is 7 because 7 cubed is 343. So this could also be written then, instead of 343, we write 7 cubed here. We see that the cube root of 7 cubed is 7 because 7 cubed is 7 cubed. Okay, so that's pretty straightforward. Okay, so generally, the cube root of x cubed is that. Okay. What would the cube root of x to the sixth be? Any suggestions? Okay, the cube root of x to the sixth is x squared cubed is x to the sixth. Now you might want to go back and review the assignment we did a couple of weeks ago, where you're doing powers of powers and simplifying things. You did pretty well that assignment, but you want to refresh yourself a little bit. Okay, so we have this. What about cube root of x to the 11th? Well, actually, let me make it cube root of x to the 4th. Well, x to the 4th is x cubed times x, isn't it? And we can do the cube root of x cubed. We can simplify the cube root of x cubed. You get this. Cube root of x cubed is x. So we've got this in somewhat simplified form. Make sense? That's very similar to what we did with the cube root of 686. Cube root of 686 turns out to be the cube root of 2 times 7 cubed. So the cube root of 7 cubed being 7, cube root of 2 being the cube root of 2. I think I have 3, that's the cube root. Okay. So, look at stuff like this. Now let me take a quick look at your assignment since we're practically out of time. Whoops. Come on, stop. Somehow.